Well, good morning, everybody. Mark Sudduth here, CJ Morgan there. I'm in
Morning.
Wilmington, North Carolina. He's down in the Sarasota, Florida area,
Yep.
getting ready to go duck hunting.
Yeah.
I pick on him. I don't know what I'm doing. I'm wearing it was hot in here yesterday. Today I'm freezing. Welcome to Talking Weather. It is December the 30th. At least we know what day it is. Yesterday was a complete disaster. All kinds of people texted me like, "What day is it?" And it was like Matt out in Colorado. He went shopping at Costco, and he said it was like it was like the zombie apocalypse. It was just nuts. Everybody's off work. Everybody won the lottery, and they're all out shopping. It was just crazy. So yeah, here we are, the day before the last day of the year, and we got some weather to talk about. We'll banter for a few minutes while we wait for people to get their YouTube notifications.
Yep.
And then we'll take a look at things. So you sent me a text, post that in the Discord
Yep.
wherever, and I'll bring that
On
up
there.
from Dylan, and we'll see. Maybe I already have it. We'll see.
Oh,
I'll
hold
look
on.
at it. Let me look at your text. Let's see what you sent me. Um,
I think he had just posted it recently.
oh, the thing about the hurricane thing from Dr. Maui.
Yeah.
Right. Yep, I saw that.
I
Yeah,
think it's
I've thought
neat.
about adding it to today's lineup,
I
but
say we do.
it's kind of deep,
Yeah,
like
but I,
I
I
don't
think we
know.
can unpack it.
Ooh,
I
there's
don't think
Watkins.
awesome. Just on time.
Awesome. So yeah, we're gonna have a guest today, and once he pops on, we'll get started. I'll at least show you guys what we have for the lineup for today's absolutely top-notch show. Cold start to
Mm.
2026 for the East. Looks like it. Florida chill. CJ can attest to that, especially tonight. He said he put the heat on.
Yep.
Kind of rare down there in Florida, right? Or
Yeah,
at least
some
your neck
houses
of the
don't even
woods.
have heaters. So
Yeah.
we're lucky ours does. And yeah, just got it cranking for the first, maybe I think second time this whole season so far.
And then we do have Tech Tuesday, which brings me to who we're going to have on. My longtime friend and colleague, Mike Watkins. We have a very exciting topic for Tech Tuesday. You don't want to miss that. That'll be coming up in a little bit. We're also going to have an appearance eventually hear from our friend Marcel. He's popped up somewhere out west. We'll see where he is and what he's up to. And then I have the old clickbait. You won't believe this. You know how you see those things like the top seven, whatever, and you have to see number six to believe it or whatever. So I definitely have a good you won't believe this. So as we wait
Right.
for Mike to jump in and so forth, and Marcel. Let's start with national high and low temperatures. I love this segment. We have two relatively new ones for since we've been doing this.
Yeah.
The national low was in Peter Sinks, Utah. I'll show you where that is. And then we have Okapi and Miles City in Florida sharing. But I find it interesting, CJ, that the national high temperature is 85. We don't see
Mm.
91, whatever, like we see in Southwest
Yeah, it's
Texas.
cold.
Yeah, we're starting to pull those low. The highs are getting lower,
Lower. Yeah.
and so once we get to today, it was high temperature. I would assume Florida is going to be knocked out. We're going to go back to either Texas or California. So
Yep.
we'll see. So where are these locations? I'm sure you're just dying to know. And I've been having trouble with my Google here. I have to refresh it and then I get my tiles back. There they are. So Okapi, and I'm sure that's how you say it because it's Lake Okeechobee. So this has to be Okapi. So
Right.
anyway, it is down there
Ask your
on the,
buddy down there in Collier County. This is
yeah,
his
Dan.
domain.
Yeah, maybe Watkins knows when he
Maybe.
jumps on. But it's kind of a small community. It doesn't even get an
Kind of.
outline for a municipality.
Yeah.
So we'll kill that. Let's drag the Google Street View guy and we'll just, oh, there it is. Oh, copy right there. So this is Highway 41, of course. And hey, I thought they banned those in Florida. Hey,
Right.
these are the jokes. Um, there's Okapi, Florida, where the national high temperature was for yesterday. I kid you not. So there you go. That's Okapi. What about Miles City? And we again got to refresh to get my tiles back. Miles City, Florida. Where the heck is that? Let's zoom out just a little bit. It's off of Interstate 75, cutting through the same general area,
Hmm.
the Everglades, right? So we'll drag our
Yeah.
Google Street View guy
I did
and
not
just
even know that had a name there.
there you go.
Driven
And
past it a couple of times on, Alligator Alley going across
yep,
the East Coast, but never knew that exit was like it had a town name.
yeah, Miles City. 85 degrees there yesterday
Yep,
for the
does not
national high
surprise me.
temperature. So that's what it looks like. So lots of real estate out there probably
Hmm.
get developed 100 years from now, unfortunately, but story for another day. But that's it. That's the national high temperatures. Let's
Yep.
kill these tabs. And how about the national low? This is up in Peter Sinks, Utah. And I've seen this when I've tracked that tweet over the
Yeah.
years. Peter Sinks shows up a lot,
Yep.
and it's named that for a reason. The way it's in this bowl, and you can
Yep.
see kind of on the image over here, the photos. But let's just drop. You're gonna love this. I did cheat, and I went
Mhm.
and looked ahead of time because I wanted to make sure it would actually do something. You're not going to believe this. So this is the road. This is, I guess, Utah 173 or County Road 173, whatever. Watch this. That is the road.
Oh, wow.
Yes, and that's the Google Street View aggregator person.
Yeah,
Look at
wow.
that. Dude, what a world where we can. I mean, that's got to be a cool job. This is where the national low temperature was
Right.
for yesterday. Um, and that's their vehicle. It says Eagles Landing travelplaza.com. These are different ads on here. This is their vehicle. What is
Mhm.
that? What kind of vehicle is this? I'm trying to figure out what the hell I'm looking at.
Is that a golf cart or a side by side?
Yeah, it looks like some kind of a little ATV deal.
Yep. Interesting, but cool.
Explore Utah, the Department of Natural Resources.
Hmm.
Anyway, that's Peter Sinks, Utah, where it was
Interesting.
minus 27. Not
Cool.
on this day. This was August of 2022. But the cold air, we'll grab that telestrator real quick. And so the cold air sinks down in here, these
Yep.
bowls, if you will, and it pools and it's dense. And so it's really easy to get these extremely low temperatures
Yeah.
um, which defies my physics. We need, again, when this show reaches 1 million daily viewers, we can be big enough to get the attention of Neil deGrasse Tyson, and I can ask him to explain to me how dense air that is sinking is cold, but you also have air that sinks and compresses that warms. How can both be
Right.
true at the same time? Some physics escapes me. But
Yeah.
anyway, so that's our national highs and lows. Let's jump on the YouTube chat and say hello to everybody today. Da, da, da. Let's see. And my YouTube has been weird too. It's just everything's weird. Oh, I never did post the link in the YouTube, the YouTube link for the show. I'm
Ah.
just behind in our Discord. So let's do that. There it is. Now I can click on it and see what we're doing. All right. Guys, let's have a ad first, of course. All right, so hello everybody. Seeing if there's anybody brand new that I don't recognize. I don't know if we've seen Albert. He's in South Africa. Nice.
Yeah, wow.
Albert Van Lingen 7590. Albert, good to see you. And
Yeah.
everybody else, of course. All right, so now that we got all that working, I got my chat up. Where should we go next? I know. Let's do this. Share the screen. So here's a tweet, and again, my it's got to be Firefox that's just really giving me issues. You know how you can update your apps on your phone? Can you update your apps on your computer? Like go in and tell it to update? Because Firefox has been goofy with me lately. Anyway,
Mhm.
my problem, not y'all's. So this was interesting. Going back in time just a little bit. You see, stuff doesn't play. It's just buffering. Um, come on. Let's go. I got something cool. There we go. So first of all, CJ, why the hell is everybody going to Florida for Christmas? What's
Yeah, I
that?
don't know. I don't know about that either.
So this is a neat animation. This is from the AccuWeather. I saw this on Breaking 911, and the old algorithm serves up weather-related content, and there it was. This is December 24th and 25th. All the flights, it looks like ants crawling across North America.
Yep.
Clearly, the destination above all else is Florida. Look at all that traffic in and out of South Florida.
Yeah.
Certainly the eastern part of the United States, Southern Cal, but that's a lot of planes. Um,
Hmm.
and my daughter and her boyfriend are one of those planes. They left on Christmas night and went up to New Haven, Connecticut,
Wow.
and came back night before last. And it was interesting because Max, her boyfriend, said that the landing in Wilmington was kind of hard. And I was like, really? He goes, yeah, it was a hard landing. I was like, I'll have to ask our pilot friend about that. What
Mhm.
would, and I know they flew in on a 737, and he said, yeah, maybe he was new. Anyway, so that's what it looked like if you were flying out there. Look at all the people leaving Southern Cal headed to Hawaii or somewhere, or Japan or whatever.
Yeah, it's insane.
So yeah, I haven't flown in a while, and no flying anytime soon for me.
Yeah.
Also, this is amazing. This is you won't believe this part. All right. So are you familiar, CJ, with that term seiche or
Yeah,
seiche?
see,
Yeah.
it's a Lake Sage.
So it's seiche, not seiche like
Hmm.
sheesh.
No, it's
Seiche.
German. It's Sage.
Thank you.
Yeah.
So this is amazing. It really is.
Yeah, they're neat.
Walking on the bottom of Lake Erie, the water level dropped nearly 7.5 feet today in Toledo, Ohio.
Yeah.
Meanwhile, the water was 13 feet higher with a wind gust of 79 miles per hour in Buffalo. A
Yeah, they
lake,
had one of the larger seiches on record there on Lake Erie. And Lake Erie is interesting. So all the lakes get seiches. It's not,
right,
unique. But Lake Erie is literally positioned and shaped just right for these to really have an effect. And Lake Erie is the shallowest out of all the lakes. So it's easier for those water levels to make a huge difference in terms of distance that it can pull the water out or force it up.
well, it's interesting because it's essentially storm surge and reverse storm surge,
Essentially, yes.
but because it's on a lake, they have this term seiche. I'll
Well,
have
and
to
that's
ask some of
because
our friends at the Hurricane Center, like, why is there a difference?
and I can tell you exactly why. When that wind relaxes, all of that water sloshes back like a bathtub.
Sure,
It's not
yeah,
like storm surge where you get storm surge and then a reverse. It's more
right,
like a slow tsunami
right,
would be the better example because once that wind relaxes, all that water that was pushed out of the west end of the lake near Toledo and Detroit has to come back. So all the water, so then, you can measure this sloshing, just like a bowl if you're, getting rattled around.
right.
But it
Let's
is
take a
it, it is
look.
a very interesting phenomena.
Look at Lake Erie real quick. Watkins has entered the chat. That's awesome. So there's Lake Erie, and I guess what was happening is the wind was coming across this way,
Yep, the fetch.
and Toledo lost 7.5 feet, and then it pinches off up here, so it was able to pile up at the Buffalo end, and they had the receiving end of the Seiche.
Yep. Yeah, Lake Erie is well known for that. It's also, the Great Lakes. There are graveyards, ship graveyards up there, especially Lake Michigan. But Lake Erie is one of the more attested, uh I'm trying to think of a word for it, like ferocious.
Yeah.
It's, it's, the graveyard of the Great Lakes. So
Well, we had Watkins, and then he disappeared.
he's still
See
there.
what happened. Oh yeah.
I just see his picture below me on
Oh,
my end.
see, I don't see
Yeah,
it.
my video feed went away. I'm gonna come right back in. I'll be right back.
Okay.
I'm not sure what happened there.
Hey, look, I'm having
It happened.
Firefox issues, so join the club.
I'm in the club already. Yeah, I'll be right back.
Very good. All right, so that's the Seiche off of the lake up there, and I
Yep.
didn't believe it. Now, I think
Mhm.
what's funny sometimes is to read the comments,
Yeah.
especially when it's not me, because you know don't read the comments they say. And again, most people are very kind to what we post. But so yeah,
There it
but
goes.
that water coming back at you strong when the wind quits. Cool picks, man. And then you always have this person. This isn't new in Toledo.
Yeah.
That wasn't, nobody said it was.
Yep.
I just, like, anyway. And then you have the biblical angle that Moses held his hand out over the sea, and the Lord drove the sea back with a strong east wind. Um, yeah, so kind of sounds
Interesting.
like the waters parted. That's incredible. Nature is still the champion of awesome.
Yeah.
Absolutely. So I thought that was really neat, and I thought I would share it with our audience.
Yeah.
Uh, the Seiche up there
Thanks.
in Lake Erie. So is Watkins back? Did he make it? I saw him briefly.
See his
I,
picture now.
I'm back, Mark, but for some reason my video starts and then it stops. I have no idea why that is because I use it all the time. So I guess it's just my wonderful voice that you'll get to hear.
All right. Well, we'll just hang out because we're going to go through a few tabs and then we're going to get to our Tech Tuesday featuring the invisible Mike Watkins. All right. So, and good to have you. And jump in on any of this stuff too, by the way. And maybe while we're talking, look at your video settings and maybe it'll work. I don't know. It'd be good to see you.
Yeah, I'll give it a whirl. If you see me disappear, that means I'm trying something new and I'll be right back
You
in.
got it. The
All right.
link is still good until whenever we're done.
All right.
All right, national map time, ladies and gentlemen, a lot calmer than we saw yesterday, but let's point out a few things that are interesting here. And that would be freezing fog in southeastern New Mexico. So yesterday we had the freezing rain, the upslope, what is that? Isentropic lift, isn't that the meteorological term? I think it is. And you had the
Orographic, you
mostly
mean?
well, but also I think isentropic. There's orographic, but
Might be.
then the meteorological. Anyway, it was coming from the southwest over the cold air that was sitting down here underneath, and we had the blizzard warnings in the mountains of West Texas. Today, freezing fog for these areas of southeastern New Mexico. And CJ, you're in this little powder blue color.
Yeah.
Thoughts and prayers. Sorry, very, very chilly down your way. Let's click on that and see what's up. Oh, freeze watch for
Yep.
today.
Yep. We got a
Cold
freeze
weather
watch.
advisory.
Yeah, and a cold weather advisory. It's, not something we get often around these parts in terms of the cold weather advisories, but like I said yesterday, if yesterday's falling iguana watch or was a watch, then today it has become a warning.
So just looking like this is out of Punta Gorda at their
Mhm.
airport tonight, 33 for a low.
Yeah,
Yeah, that's pretty chilly down there for Florida.
yeah,
I'll give you that. We won't besmirch you too much, but yeah, the Arctic air has finally made it down into the Sunshine State. And it won't be too long lived, though. That's the good part.
no.
Fog is back in the California Valley there. I can see that. And
Yes.
then what is all of this interesting color up here? We're going to have more color. Yesterday, it's a dense fog advisory. I
Yeah.
gotcha. So
Or
air
air
stagnation.
stagnation advisory.
Wow.
I've
I have
never
never
heard of
seen,
that.
right. Like you walk out and it just, you know, it's
That just
stagnant.
sounds awful.
Just hopefully it doesn't smell like Hereford, Texas.
Yeah. Oh God.
And I don't want any emails about it because you guys know, yes, it's pretty stinky there. So the reason that we do have this stagnant air is from an inversion.
Ah, okay.
Long periods of high pressure move into the Intermountain West in the winter. Cold air lingers in valleys. We were just talking about that a little bit ago with Peter Sinks, Utah, due to light winds and limited mixing. And the cold air becomes trapped, making it easier for fog to form. And
Yeah.
pollutants and yes, cow farts are pollutants. They get
Yeah.
settled into the valleys. And
Okay.
you have a similar setup in parts of Texas with these big feedlots,
Yep.
and the air doesn't move very much and it gets stinky. So up
Yep.
here, it's a different setup, but the low mixing heights, etc. Interesting. So air
Oh, interesting.
stagnation advisory for people in Southeast Oregon and Southwest Idaho. There you have it. What is this going on up here in North Dakota? An interesting peach color, I think that is. we can agree that's peach, maybe? We can
Yeah.
get into that again. Oh, it's a special weather statement, of
Yeah.
course.
There it is.
So that's okay. Red flag, I know that for Georgia. And I don't understand why not South Carolina? Why not Alabama? Why not Tennessee?
Why not
Why
North
is it
Florida?
only windy and low humidity in Georgia? Like,
So that would be, I think that lines up almost perfectly with WFO Atlanta. Well, Peachtree City.
right, right.
Yeah. So I guess each one has their own criteria. So I don't know.
But if we zoom in, click it, it says
Yeah.
much of North and Central Georgia. So, you leave Rome, Georgia, and head to the west into Alabama, you're good to go. Don't worry about
Yeah.
the red flags. That's just interesting how that works. Meanwhile, up in the Great Lakes area, windy still with lake effect snow warnings, winter storm warnings, you name it, coming off Lakes Erie and Ontario. That'll persist for a while longer. All right,
Yep.
what else do we got? Oh, yeah. I saw this just random thing. I thought, oh, that's interesting. I'm going to read it because it just sounds interesting. Rain associated with an anomalous low pressure system from the tropical latitudes is forecast to bring the threat of flash flooding for Southern California on New Year's Eve into New Year's Day. I was like, wait a minute, like, I haven't heard much about this. It's not like something that everybody's talking about. And I looked at the satellite, and lo and behold, there you go. And so, again, they started off 2025 with hell on earth fires, and we just had a lot of heavy rain out there, and now the threat again here of some flash flooding, but it doesn't really show up yet on any of the guidance or communication methods here from Southern Cal just yet. Uh,
Right.
and I mean, widespread to moderate precipitation, I mean, a little bit here, but I would expect that there would be green for flash flood watches, but
Yeah. Wow.
not yet. Anyway, if you're in Southern California, pay attention because an anomalous low pressure system from the tropical latitudes, that's just an
Yeah.
interesting way to put it, is headed your way. So be ready. All right, a post here from Dylan. This is more along the lines of what we were just talking about. He posted this a little while ago. December drop. Very good, Dylan. And we will
Yep.
wake up to widespread 40s across South Florida tomorrow morning.
Wow.
The iguanas won't like this forecast.
No, they do not.
So I need to use Sora and create a 15-second video, and I'm going to do it
Yeah.
later. I'm going to tag Dylan. I'm going to throw it on there. In fact, I can do it during the show because it's going to be
Right.
apropos to what Mike's going to talk about. And I'm going to drop it on there and I'm going to tag Dylan. I'm going to do an AI generated video of iguanas protesting the cold in Miami. So let's get started. All right, let me jump in here to my Sora app. This is a good way to use billions of watts of electricity to generate slop, by the way. A great
Yep.
use of the technology. So we'll go into my Sora. I'm going to hit the plus button, create a video showing iguanas protesting the cold air that's coming to Miami, Florida, and vicinity. All right, that's the prompt. We're going to go up here. We're going to do this one in portrait so that it looks good on social media, the old TikTok look,
Right.
and we'll make it 15 seconds. Why not? Let's just use thousands of gallons of water and millions of microwave hours of electricity to generate this slop. And then the last part, make it look like a TikTok video. And I hit submit and we wait. And somewhere somebody's power just went down a little bit and their water pressure dropped. When this is done, I'm going to download it. I'm going to tag Dylan and we will show the world. All right. All right. So I think we might have Mike Watkins back. Maybe. I see a little bit of something over here, a little life. I have to ask him to unmute. Uh-oh. We're getting closer.
I got audio and a black square. It's still night in South Florida. That's why you can't see me.
There
Yeah.
you go. It reminded eventually we will have dinosaurs on this dinosaur tour.
Yeah.
Hello?
Hey, Mark, there's who's paying for your AI
Right,
slop.
right. Yeah, I just generated an AI video, or it's doing it now, based on this tweet here from Dylan about the iguanas won't like this forecast. And I was joking, which actually it's actually true, that think about the thousands of gallons of water and all the electricity that my stupid prompt is costing somebody right now. And apparently it's Watkins because his camera doesn't work. So sorry, Mike.
Yeah, what are you gonna do? That's fine. I mean, it is. Yeah, I'm guessing Colin's also in South Florida or close to here, but yeah, it's gonna be
Yep.
like 45 tonight or something like that. It's crazy.
Yeah, it's really
Indeed.
cold for you guys down there. I'm in the Tampa Bay area. I'm in Sarasota, so it's a little bit cooler up here, but we get down into the 30s every so often. You guys, it's very rare. You guys make it down into the 40s.
Yeah, especially this time of year. So yeah,
Yeah,
we're looking forward to it. The windows are open for sure.
nice.
So CJ, you reposted this
Yeah,
yesterday. Fire weather makes a return to Florida this week. AI jokes and whatever aside, want to be serious as much as we can here. And fire's a big problem. Obviously, we saw that. We started the year with that terrible
hmm
situation in Southern Cal. Now it's the fire weather, the setup for it is making a return to Florida. And you can see that. CJ, that's something that is on the SPC maps. And I don't think a lot of people know that because
No,
you don't
a lot
think
of
of,
people don't. It's not something that's really focused on
right.
all that much. But yeah, today and tomorrow we've got 2 days straight of elevated fire risk from the Storm Prediction Center. Here for today, it's the entire state
Yeah.
essentially,
Yeah.
other than the Keys and extreme South Dade. And then you have tomorrow where it is basically the entire peninsula and the
Right.
Panhandle and the Big Bend of the Panhandle.
And
So
the
yeah, it's going to
reason,
be
yeah.
um it's a problem. And Mike, I know you guys down there have gotten a ton of rain the last couple of rainy seasons, but it's our dry season. It's nothing that we're not used to here in Florida for certain.
So burn bans in effect down there, just be
Yep,
aware of it. But let's don't leave out our friends in Texas and Oklahoma. That's elevated as
yep.
well. But just to show you guys, let me kill my telestrator because my hotkeys will interfere. There we go. So if you go to the SPC site, it's on here. You just have to know where to look. You go up to SPC products. There's all forecasts, mesoscale, etc. But then right there, fire weather outlooks. There it is. It goes out to day 2, and this is what we were just showing you. So just be familiar with that um, going forward. I thought that was an interesting post, and that CJ reposted because he is in Florida. So I thought I'd bring it up. And in looking at the drought monitor for the country as a whole, we click on the southeast. It's getting there.
Yep.
Most of Florida in some kind of drought for sure. And Georgia, Alabama, and some of those areas in that red and the panhandle, extreme drought. So just pay attention. Be careful out there as things get drier and the lower humidity values with higher wind. We don't need any big time fires popping up. And CJ, you're right there, just near that orange color, right?
Yeah, so our
Just north
area is
of you.
we are within the D2, the severe drought. And I mean, this rainy season was pretty lackluster here on the West Coast, for reasons that I'm not going to get into because it'll take too long to explain. But
Right.
we've been running in a deficit all year. Seems like after Milton and Helene last year, the tap just kind of shut off for our side of the state. And a lot of the storms this year went to the East Coast because of a prevailing west wind. So we didn't have any, thankfully, did not have any tropical systems, but that's usually where we make up our deficits is during like tropical storms or hurricanes.
All right. So I wasn't ignoring you. I have the video ready. I'm going to
Oh
share
Lord.
this. They are already protesting. Boom. Share that video. And I need to, before that pops up, just to make sure that we know who Nanda is. Where is it? Green room. Okay. Sorry, folks. That's just making sure. Are you Nanda? Question mark. making sure this is our friend Marcel and not some random person that we see something we don't need to be seeing.
Yeah.
So while we wait for that, let me show you uh, this video that I just generated. Oh, there it is. They are protesting.
That's phenomenal.
Far we've come in the last 20 years, Mark.
I know.
Nope.
All right. All right. So there you go. Dylan, you asked for it, buddy. I'm in the mood. So you have an AI generated iguanas protesting because he said, I mean, he set it up, man. The iguanas won't like this forecast. So there you go. Um, so as I wait to hear back from whoever this Nanda, I think that I know who it is. Yes, it's his wife. All right. Fernanda, of course. So we're gonna let Marcel in, and I'm gonna go ahead and bring him in quickly here. Let's see if we can get him. And we're gonna show you where he is. You're in or on.
All right.
There he is.
There he is. I thought you
Hey
were gonna be
guys.
outside.
No, I mean it's kind of cold.
Oh well, we
Yeah,
got you beat
well,
over here.
Yeah.
yeah.
So this is Marcel, and he is where? Where are you at?
Actually in Pacifica, which is just south of San Francisco.
Terrific. And you went
Yeah.
out there with Fernanda and your mom, right?
Yeah, she's visiting us from Brazil. I mean, she's leaving like 3 days now, January 2nd. So we're gonna
Okay.
go ahead today, probably visit Yosemite Park,
Oh,
Yeah.
wow.
and then we're gonna go to Los Angeles so I can watch a Lakers game.
There you go.
There you go.
Maybe we'll see you on the front row and you can, heckle LeBron or something. I don't know.
Oh yeah, oh yeah.
Hey, Watkins, maybe we should put some money on that game and we can get Marcel to sway the outcome. I think we might have lost Watkins.
No, I'm
Oh,
here. I'm still dinking around with the video settings, but
that's all good.
You're an analytics guy. What could we get Marcel to do at the Lakers game? And we can jump on Polymarket or DraftKings and make a little moolah. Of course, I'm probably committing a federal crime by just talking about it, but
yeah, I'd say encourage a player to bet the to come in under certain stats and then do some unusual market. But the weird thing is, not the weird thing, but luckily the betting markets can identify unusual trends in betting activity, so they probably shut us down anyway.
Interesting.
So
there you go. Well, that's pretty cool, Marcel. And so it was a good trip out there. No weather to slow you down.
No, actually, we got a lot of rain in Wyoming while we were visiting like Jackson Hole.
Oh
And
man,
yeah, I mean, it's kind of unusual for them this time of the year to get rain,
yeah,
right? And
true,
and a lot of rain. I mean, it was a
yeah.
lot. But after we crossed to Utah, I mean, the rain stopped the next morning, and then it's been sunshine since then.
Oh, wow.
Well, very good. And what does your wife? So you and your wife went out west a few years ago, so it's not her first time out there. But your mom, right? This is the first time in that part of the country.
Oh, definitely. I mean, by now she knows more US than Brazil.
There you go.
Wow.
We're doing the counting how many states she's been to. I
That's
mean,
awesome.
definitely more than Brazil. I mean, because it's way easier here to travel.
Sure.
Right.
So, question for you: has she been to a Buc-ee's yet?
Oh, definitely. I took her when I was living in Florida.
Right.
Definitely.
That
Yeah,
was easy
that's
to do. All right.
yeah.
All right. Well, that's cool. You gotta post some pictures from your travels on our Discord when you get a chance. We'd love to see them, and we can share them. And wish you safe travels. And when you get back to North
Yep.
Carolina, we'll have to get together and start thinking about next year.
Oh, definitely. I mean, I'm going to LA, probably going to get a lot of pictures on the rain the
Terrific.
next few
Hey, we
weeks,
were
few
just talking
days.
about that. There's a anomalous low pressure area from the tropical latitudes moving in. and you have to be aware of that. So yeah, you get any mudslides or debris flows, by all means, dial us up. But first of all, be careful, of course.
Oh, definitely. I got some experience with that, right?
Yes, you do, for
Riding
a
along
weird
some
reason.
guy or some
Yes.
guy that I know.
Yeah, yeah. Well, I seem to remember us almost getting stuck out in Texas somewhere in debris flows and the whole landscape just going by.
Yeah, yeah.
Yeah,
Actually, it was Oklahoma. Remember, we were
oh,
in
that was Oklahoma. That's right.
Oklahoma. Yeah.
He's got a better memory than me. We'll have to have him help me produce my podcast shows. Well, cool, man. I appreciate you checking in with us. We're gonna slide over to our Tech Tuesday segment in a minute. Feel free to hang out. Not getting rid of you, but Mike Watkins keeps popping in and out. He's trying. Even if we just
Right,
have
man.
a voice,
Yeah.
that will work just fine. So I'm going to jump on here and move over. We covered that. Yeah, Tech Tuesday. So the silly little video that I just shared here did have more of a purpose than just being silly. This AI generated Sora 2 is the app. It is from OpenAI, and you can create all kinds of silliness like this. But there's a lot more applicable applications, to use that word twice in one sentence with different meanings, whereby it is relevant to what we do here, and that is the world of AI and weather. So I'm going to stop the screen share, even though we can't see him. I want to bring in my friend and colleague from long time ago, Mike Watkins, South Florida area, to just talk about AI weather. You know, I was joking when people were talking about Google DeepMind and the Google forecast, the Google this or whatever. You know, oh, you mean the search engine and the Google Ads people? Now they're forecasting the weather. And you just joked a minute ago, we've come a long way in 20 years. What the heck is going on with this AI stuff? Because this is literally right up your alley.
Well, thanks, Mark. Yeah, so I mean, since we've been doing this, right, we came from the regional models, which was the old avian for aviation model that became the GFS global model that then it kind of in tandem with the whole story with the euro that obviously that would take weeks to describe what happened with that. But we've been using these physics-based models to project the future. And I don't know, but recently, and I'll just kind of summarize it, and then we can get into the detail that you want. Over the last few years, the computational power of computers has drastically improved, and we've had some revolutions in how we use computers to predict what's going to happen with the atmosphere. And so, within the last couple of years, even going back to 2023, even global the Google and now the Euro, the European Center for Medium Range Weather Forecasting, have been implemented just recently, within the last couple of weeks now. The US with the GFS AI suite have been using AI-based models instead of the physics models, or in addition to the physics models, to project the state of the atmosphere out into the future. And it's really changed not only how they generate the forecast, but how quickly that information is available to be used as well. So
Right.
it's fascinating.
So let's start at the beginning. When we talk about physics-based models, as best as you can explain it, what does that mean? Physics-based.
Yep. So the idea when you know we when they I'm going to use we. I wasn't involved in any of the development of the physics-based models, but we as a weather community,
Yeah.
or we as a modeling community, um, uh, began to solve equations. Differential equations. Solving basically math and tiny grids across the globe. And so, as a lot of our viewers and listeners probably know, we run basically four sets of global model, or each global model, US, Euro, and then the multiple others from the around the world are initialized twice a day using observations from all over. And then
Those are your
that data.
synoptic times.
Yep, exactly. So 0Z and 12Z, so 8 a.m. and 8 p.m.
Mhm.
locally here in the summer. Um, to capture as best as that we can the existing state of the atmosphere, and then using what we think we know about physics, calculate how the atmosphere is going to move. And so each one of these global models, if you just kind of think of them as three-dimensional triangles that really, or square cubes, or that basically capture height and distance, uh, calculate and
Yeah,
solve
spatially. Yeah.
equation. Yeah, exactly. They solve kind of uh, uh, they they create projections within each cube, and then these cubes kind of interact with each other cube, and then from there, essentially, we generate a picture of the atmosphere as it exists now as best as possible. Then an hour from now, then that gets
Yep.
done all the way out to like 384 hours with the GFS. But
Right.
this is all based on what we think we understand in terms of differential equations and physics and the atmosphere. And so
Gotcha.
there's a lot of unknown happening in there in the atmosphere that we can't simply we don't either know how to detect, or is it such a small level of detail that it's not useful by the time the model is finished. So there's some trade-offs there, but ultimately the physics-based models are our science-based, this is how thermodynamics work type of
Right.
projections.
Right.
And that's been the gold standard for really for the last 30 years or so,
Sure.
because before that it was all statistical, like at this time last year on this date,
Right.
in this pure area of the tropics, for example, this is where hurricanes moved, and that was, the beginning of the thing. And then we went to the physics-based models, which had been the leader up until just the last couple of years.
So then enter the realm of the LLMs, the large language models. And I understood at the beginning of this, which is really only a few years now, where it really ramped up. I realize AI and all that goes back much further. I understand the history a little bit, but really these last 2 to 3 years, this term LLM, basically you think about OpenAI or Anthropic or Claude or whoever, I guess maybe some of them are the same, that they ingest kind of like the entire internet to learn from. And so you're talking just unfathomable amounts of data to create all of this stuff. That video that I posted of iguanas protesting is from trillions of data points that created that. I don't know how the hell it works. I honestly don't. So I thought about weather, that there's only a few thousand observations per day going back to 1850 at best. That's not even close to consuming the entire internet. So I thought, yeah, it'll never work on the weather. I really did. Like a couple years ago, yeah, there's just not enough data. All the weather balloons that get launched, you look in just the country, all the obs from all the planes, it's not even close to the amount of data that's on the internet. You think about how many hundreds of hours of video get uploaded to YouTube every day. And you have Facebook, you have Instagram, you have all these PDF files. The internet is giant. It is like a miniature universe. And that I can understand, where if you can learn from that, then the AI starts to grow. So I thought weather, there's no way. Yet here we are. How did we go from LLMs to predicting the weather? Literally, like I said, let's try to be comedic about it, but really the Google Maps people that tell me my destination is on the right now can tell me when a hurricane is coming. How did we get there?
Yeah, that's a great question. And so I think there's a bit of a distinction between what the DeepMind and GFS now and the European AI-based models do, and the large language models in general. So if we've been at some kind of level using tokens, or essentially sequences of letters that create words, that create sentences,
Right.
forever, right? So as you go into Microsoft Word and you type in a word and it's spelled incorrectly and you get a suggestion, the model's essentially, locally saying, "Oh, you're probably trying to spell this word," and we've been kind of using that on a very small scale, but within the last 5 to 10 years, that's rapidly expanding. And so every time you go into a large language model and type in a sentence or ask it a question, it's taking those tokens or words that you've entered and then making probabilistic determinations on. That's kind of a oxymoron, probabilistic estimates of what you're attempting to understand, and then it gives you back based on all of the context that it has through what you've entered in your prompts and what you've told the projects, plus all the information within the corpus of the large language model, what you're discussing. And that's become, I mean, and anyone who's used it, especially to generate images or to, because just like the video that you just showed now with the freezing lizards, it kind of gathers the context of what you're talking about. They're forming a protest, right? And they're in Miami and they're cold. And so the model takes all of that information and then creates a projection of what it thinks that you want it to show you. And that's how you kind of get that model.
Crazy.
With,
Yeah.
or that's how you get that image.
Right.
But within the weather space, the deep Google DeepMind, for example, is more of a neural network. So with neural networks are a way or a modeling technique that's been around for about 20 years or so, that through the construction of the model itself, there's layers, there are nodes, there are hidden nodes, there are hidden layers, there's different connections through there. But the idea is essentially to try to simulate how the human brain works in terms of structure to put in a prompt or a question, and then or in like what I do for a living, like for example, like which customers are most likely to cancel their subscription in the next 20 days or something like
Right.
that. And then we can build a neural network that will predict that based off the training data that we give it. So the weather models are essentially massive neural networks that are initialized not just with all the physical observations and satellite data and everything that we already have, which all of that goes in there. But then instead of using physics to kind of use these grids that talk to each other to project what might happen over the next hour, they vectorize the motions of the, sorry, let me go back. Vectorizing meaning trying to take a specific part of the image that it has essentially, right? And then determining based on its current motion and location and relative distance from other features and that type of thing, where the atmosphere, what the atmospheric state will be in the next hour, and that feeds forward again every hour through however many, 384 hours, that type of thing. So it's using the computational engines that we've built for the large language models, but doing something what much more advanced, which is basically trying to take the existing state of the atmosphere and then using all of the motion and interactions and the things that it can bring into the neural network to predict what the next state or the next hour is going to look like. And then that next hour becomes the initial condition that predicts the next hour out in the future until you get out to 384 hours. So instead of doing all of these super incredibly mathematically challenging engineering math type of solutions in physics covering space and time, it's basically, I don't know, the easiest way to think of it might be just trying to figure out where a pixel is now on the weather map and where that pixel will be in the next hour. But ultimately, huge amount of resources to run these things, but it
Right.
just happens so much faster and it's much at scale, so much quicker than we can get from the physics-based models. And we're finding through validation, and I'm sure we'll talk about a couple examples today. It's currently outperforming the physics-based models. So there's a lot more that we don't know about the nuts and bolts of physics in the models versus what we can derive from observations and what the neural net themselves can see and project into the future. It's just a lot more efficient as well.
Well, we're talking with Mike Watkins here on Tech Tuesday on Talking Weather. This is fascinating, and it blows my mind. I mean, Marcel, CJ, what do you think about this? I mean, just a few years ago, this was not a thing, and now Watkins just said that it's blowing past our traditional physics-based models, and I don't understand. I don't, and I think that's important because a lot of people don't understand it, and so what we don't understand sometimes becomes a little scary. Oh, we can't hear you, Mr. CJ.
Sorry, how about now? I wouldn't say it's scary. I would say that
To some
it,
people, it would be.
yeah, but I mean, it's very interesting that, I mean, it kind of goes without saying. You almost think to yourself, well, does the weather not behave according to the laws of physics? But
Right.
evidently, there's something we're missing on our current and we do know that, there's so much in meteorology that we still don't 100% know. And I mean, it's evident,
Right.
I don't know, Mike, do you think we're getting lucky? Or do you think that, like what is your take on it? Because you've worked with these a
That's
lot
a good
more than I
point.
ever have. I just look at them. I
Right.
look at the completed, forecast.
Yeah, no, I think the sample sizes are big enough, and the phenomena that are attempted to, that are being predicted, the kind of the portfolio of different forecast tracks, whether it's a winter storm or a tropical
Right.
cyclone or a tornado outbreak, for example, there's enough in the samples that we can gauge the prediction from the National Hurricane Center, which
Hmm.
tends to be a consensus of the
Multiple.
various global models and some of the
Right.
regional physics models, and that these within and definitely this year, but the last 2 years also in testing, the a long track, meaning how fast the storm is going to go versus how fast it
Mhm.
actually went, and cross track errors, meaning where did we think it would be in terms of its motion, vector, um, have reduced, the errors that the forecast errors from the AI products have consistently outperformed the
Right.
physics-based models, and enough times that it's no it, it the
Not a
samples
fluke. Right.
plenty flat powered, yeah, has plenty of statistical power to say
Right.
that within a 95% confidence interval, we're outperform, we can say for sure it's not luck. There's something other than randomness that's causing
Right.
the improvement in skill.
What
Right.
about intensity? Is the AI still, that seems to be like the next part to tackle because rapid intensification, that's the
Right.
big nightmare, even as we approach 2026 here.
Yeah, well, that's a great question, and that's going back to, like, I don't know, Mark. It might have been the 2005 National Hurricane Conference, or 2000. I don't remember. It might have been Florida first and then national. But I know we've always, since we've been doing this, talked about how our ability to forecast where a storm's going to go, although it's somewhat dependent on intensity, right?
Right.
Because the deeper the storm, the stronger the storm, the further up in the atmosphere it
Right.
extends, and therefore it's exposed to different steering currents. But has really been we're getting better at track, but we're not improving as much as we'd like in
Exactly.
intensity.
Exactly.
And so these models have also improved that. So, like, for example, the Google AI operational DeepMind models, and it was the current with all the I've already forgotten the hurricane that smashed
Jamaica?
into Jamaica. Yeah,
Yeah, Melissa.
but Melissa, yeah, there's so many M storms that have been problems in the Caribbean. They mix together in my brain, but all of the ensemble members. So much like the Euro and the GFS has kind of different ensemble members that get
Mhm.
initialized with
Right.
slightly different variables. All of the members for about 36 hours before landfall were suggesting that we'd be dealing with a Category 5 hurricane. Like, every single member of the AI suite was saying Category 5. And,
Wow.
what we found, through the record 257 mile per hour drop wind sonde that was deployed right before it made landfall, the model turned out to be right. So the scale of improvement and intensity isn't quite as large as track,
Right.
but it you know it's performing as well or better than our current intensity aids as well. So yeah, it's helping because and it was just like CJ said, there's so many things that we either don't understand, or there's a lot
Right.
of uncertainty in what we think we
Mhm.
understand, that kind of gets taken out of the math because we don't know if our differential equations are perfect. We don't know if they're calculated at the right scale or if the resolution's good enough. But the model doesn't really think about that, right? It's really
Right.
looking
Right.
more
It's
at
not
the
thinking
motions.
about the
Right.
math or the, and that's what it kind of, I think people don't understand. It boils down to is that when you're working on just sheer vectors, all, like you said, all it cares about is where's this, pixel essentially going to be in 36 hours. It
Yeah.
doesn't, it's not going to it's just going to say, okay, I think it's going to be over here because everything else is moving in that direction versus I need to actually calculate based on this equation, use this parabola, like I'm obviously being a little bit
But
facetious there, but it's not going through the actual mathematical equations in the same way that our physics-based models are.
But that's not might be another problem, CJ, is that
Mhm.
people would rely more on AI and
Right,
stop like doing the research in math or
right.
meteorology, like relying more on AI. So
Yeah,
probably we're gonna have some impact in the future in the research about climatology,
you
maybe.
very well could. Yeah.
That's a
Yeah.
great point, Marcel. What do you think about that, Mike? Could this eventually, well, the AI's got it. So, and I'm going to show a tweet in just a minute from Eric Schmidt that, well, not for, you'll see, but there is the thought that AI will replace people. Could this
Yeah.
be one of those situations where, the AI's got it, so we don't need any physicists and mathematicians anymore. You guys are extinct.
Yeah, well, the hope is that, as a culture and as a society, we continue to value the sciences and to pay the people that are doing this to keep doing it and not, generate, take the efficiency and say, we don't need, forecasters at the National Hurricane Center, or we don't need the GFS model anymore because
Right.
we have this AI. The hope is that that doesn't happen. What is interesting about the newest the American GFS forecast suite that's come out, that'll be deployed in time for the 2026 season is there's actually a third. So if you think of, we have the physics-based models, we have the AI models, but the GFS is also going to have a third component, which is taking the solutions from the AI-based models and the physics-based models to combine those into a consensus forecast. So I think the
Right.
earliest
Wow.
example we can think of is the Florida State Super Ensemble, which is still
Yep.
not public but has been out there
Right.
forever.
Right.
Um, so that idea was to, identify statistically which models had the best handle on a specific storm and then kind of push weights toward their solutions while they continue to perform. So kind of an in-storm type of deal. But this combination of the AI and the physics, that ensemble forecast is actually outperforming, or did at least in back in testing this year and last year, outperformed either of the AI or the physics-based solutions. So
Wow.
at least what we're seeing so far in there is that there's still definitely value from the physics-based models. It's just a different value that when combined with the pixels and the vectors of motion and that type of thing that are generated from the AI, you get a better forecast. The
Yeah.
the
Right.
the other thing I haven't really mentioned this so far is it takes hours, right, from the initial time before the global models are ready.
Yep.
As we all know, they initialize around 8 a.m. and we're waiting around at 12:30 sometimes in the afternoon before the solutions start coming out.
Hitting
Um,
F5, F5, F5,
Exactly.
refresh.
But we can, the AI models can basically complete within about, I don't know, I mean, less than an hour, but sometimes in minutes,
Wow.
the solution is available with the computational power that we have. So there's going to be use cases for both, but at the moment, at least, I don't think the physics models are under any threat.
Right.
What I would be more concerned about is like how individual forecasters would use the data to communicate uncertainty and to generate forecasts. I don't have any worries that our friends at the National Hurricane Center or National Weather Service are on that path, at least at the moment. Again, politically and socially speaking, it's I think going to be more important to continue to insist on the value of of the science, because I don't think you can have one without the other. I don't think we'd have the AI models being as good without the physics.
Right.
But now the physics are going to become more and more dependent on kind of the AI solution. So it's really just like back in the day when it was the statistical model
Yeah.
versus the global versus the regionalized GFDL, and now HWRF and HMON and all those. They're all different tools that work together better than any one independent process does. But the US use case with the GFS kind of combining AI and physics to get an ensemble forecast, that's the first I've seen that done. And I'm not surprised that it's better. But that it just I don't, because they just came out with that at the end of beginning of December, I think. I don't think there's been a lot of time to kind of process and understand how that's going to work. And I would imagine that by the time we get to June of next year, when the Atlantic hurricane season starts up again, um, uh, there'll be a lot more discourse around how all these tools are going to work together.
I mean, it's
Interesting.
deep. It's moving so fast.
Yeah.
Wow. Um, we got to get you back on sometime too, where we can look at some case studies. Obviously, we can get your screen to share and get you on the video working. But this is a great introduction with a lot of questions brewing up in my mind for what we could do to discuss this further down the road. Maybe get another colleague in from the Hurricane Center or somebody from INSEP, almost like a round table, because it is moving fast and, it's very costly too. Lots and lots of money getting poured into AI, these data centers, and figuring out how to pay for all of it and how it's going to make money. There's just a lot of questions, Mike. Like we're right at the beginning. I feel like um, there's a lot of hype and a lot of hope. And like you said, we hope that certain things don't happen, but we also say in our business, hope is not a planning tool. You have
Right.
to
I
have a
hope
plan.
is not a strategy. Yeah. So
Right.
if without getting too into the weeds on it, but like the work that I do, 20 years ago, we might do something called a decision tree model that,
Hmm?
once you bring in the features, you kind of have the most important splits. Did this thing happen? Yes or no? The biggest split becomes the first node in the tree, and
Yep.
then you go to the next split, and then you end up with a prediction, right? Then we came, so then we took these decision trees and said, what if we changed the input values just a little bit in each one of these trees to account for uncertainty in our ability to measure the initial conditions or whatever, and do that randomly, and then take the consensus of all of those trees and
Yep.
make that the forecast. That was something we call a random forest.
Yep.
And then the next step is, all right, well, let's take all of these forests of trees and change the initial starting conditions in the forests of the trees and then group those all together, and then make a prediction. And that's called something that most of my predictive models that I build are gradient boosted machines. So they're basically forests of trees, right? So individual predictions, consensus, then bigger and bigger consensus. And that process, while not perfect, generalizes better than, say the old statistical
Yeah.
logistic regression models or some of the other ways that we used to do things, but not necessarily outperform the neural networks. But it's those ideas. So the more uncertainty that we account for at scale, the better our predictions are when we generalize in the future. And so that's happening at absolutely, it's happening at light speed right now across every domain, not just the weather.
Yeah.
But yeah, ultimately my concern is, are we going to run out of resources to continue to
Yeah.
grow, or are we going to run out of money to continue to fund the resources to
Right.
continue to grow? And those
Right.
are the big questions. Yeah.
Yeah. There's definitely talk. Is this AI thing a bubble?
Yeah.
All these companies, and it's a lot of money getting pumped into it. And there has to be something at the end of this beyond being able to create AI generated iguanas protesting the cold in Miami, and joking, obviously, that, just, the comedic aspect again, we're seeing some results, but the amount of money being put into this, You know, you have Google DeepMind and the Euro, ECMWF folks with the AI weather and GFS and INSEP finally coming on board. How do you monetize that? Because this is very, very, very expensive, to get to where we are. And those are stories and questions for another time because we are still so very much at the beginning of this. That it's hard to keep up. There's podcasts about it, some that are kind of scary with all these, things like the singularity and AGI becoming rampant. And to the guy that owns the Twitter there, Musk saying that, within just a few years, nobody's going to have to work anymore. All right, well, how the hell are we going to have income? Well, it'll just be universal income. I started thinking, oh, we're headed towards that movie Wall-E, and we're all just going to
Yeah.
be sitting around having our cheesecake factory in a cup.
Yeah, well, we recline on a cruise ship. Yeah, I mean,
Exactly. The
and
axiom.
yeah, is that what it was called? I forget.
Yes, I have a terrible knack for remembering minutia like that. Um, no splashing, no diving. That's where we're headed with this if some of these predictions come to pass. And I sit there and I think, that just doesn't make sense to me. How would all this happen? Yet, I didn't understand just 2 years ago. I thought, because I didn't understand, that was the point. I thought that AI was built on gigantic amounts of data. And since there is not that much weather data, even on a singular day, there isn't. You're only talking about a few thousand points of OBS around the world, and you
Mhm.
need such infinite amounts to create these lizard videos. And yet I was wrong because bam, Google DeepMind, it was literally mentioned in tropical cyclone discussions, and my
Yep.
mind was blown. Like, I'm reading about the company that, again, jokingly, your destination is on the right. That would be a
Yeah,
great name for an AI book about weather. Your destination is on the right.
yeah,
There you
or I'd say it's probably on the right,
There
based on the
right.
probabilistic output. But and that's the thing
That's
too,
a good
right? It's like
parenthesis.
there's all of the data that we have, that humans have created in books and
Right.
visual mediums and all of that, and that's being currently used to train or to teach the models like how to solve these problems, and then using unknown future data. That's when we actually generate the
Right.
forecast that we validate, right? The next
Unknown
big
future data. Just say that.
Yeah, exactly. But I think the next big step is going to be at some point soon, we're going to start using the data that the models generate to train the models
That's
themselves.
right. I was
And
worried about
that's,
that with the video stuff. Let me jump over here real quick. They talk about slop. Casey Neistat, the famous YouTuber, as soon as Sora came out within just a few days, he did a terrific video on YouTube about AI slop. And I mean, he might have even coined that term. I don't know. It certainly became popular once he said it. And I started thinking about that. If AI video and if generative AI is learning off of images and video, what happens when it starts learning off its own slop? Like, yuck, that doesn't sound good. So anyway, that's where I was.
well,
You keep
that's the
leading me down
danger.
these questions, right? That's the
That's the
problem.
thing. So, like, for example, and this is just another business example, right? Well, so let's say that I work for a company and there's 10 million potential customers that we could contact with a marketing effort, for example. But we only can afford to evaluate, we can only afford to contact 1/10 of that. So 1
Yeah,
million. So my job would be, of the 10 million people that we can contact, which million are the best ones that'll be the most responsive?
makes
One
sense.
way to do it would say, just, build the model, take the top 1 million, whatever it is, use that to do your campaign, and then take that data from that subset of that 1 million people subset, and then train the next model.
Yeah,
You can do that, but the problem is now you've created something called selection bias, right? So
yes,
they got into the first model, but we don't know what would have happened with the other 9 million had we
right.
contacted them, because we didn't. So instead of using all 1 million contacts on them, I'd probably recommend, all right, take 80% of your budget and focus them on the top, 800,000. But then let's do a random selection out through the rest of everybody. So that way all the potential options are represented in the model.
Right.
So that way, when we build the next model, we can still generalize from the people that maybe didn't respond, that we, or the people that weren't going to be selected, but did because we brought them in. So now we've removed selection bias, but we also might learn something that we didn't think about or didn't know about when we built the first model. There might be some segment of customers within that envelope that become highly responsive. We just didn't understand because something's changed in the market or we couldn't measure it. So that type of discipline has to be, it's absolutely paramount
Right.
to prevent the models from basically training themselves into a giant case of selection bias.
Right. Yeah.
Yeah, wow.
Marcel, CJ, thoughts? I mean, this is wow. I mean, CJ, I see where this could maybe help in the future with tornado genesis, and then
Right.
tornado could go, because that is still such a big unsolved mystery of why
Yeah.
some supercells create tornadoes, and then you're talking about such a very small scale. Go back to those grids that Mike talked about, throwing AI power at tornadoes. That seems like a logical deal. Flooding, predicting which areas could receive flooding. I mean, there's just a lot that could be done with this, where the lives saved and then the monetary return. But still, if you save, obviously you can't put a price on a life. We get that. But if you have
Right.
$1 trillion invested in AI technology, just spitballing, and you save $30 billion in damage, it's not a good investment, like on paper. That's all I'm
Right.
saying. Like the cost is going to have to come down. And you're going to look out your
Yeah.
window, there's going to be data centers everywhere. And my
Right.
Yeah.
water, I won't have any water to drink. I don't know if this is hyperbolic, but your electric bills will be high, the water will be taken by the AI company, blah, blah, blah. We're just in a new world, Mike. And the thing I keep coming back to, as far as I know, nobody asked for this. There was no, like, you know what I mean? Like it just kind of
Yeah.
happened. A bunch of 20 and 30-year-old dudes got together and said, "Hey, let's do this." And there's no control. And now the current political climate, there's even less control is mandated from the top that the states cannot regulate AI. Okay, that's great. Um, and at least with the Manhattan Project in the 30s and 40s, there, it was all part of a bigger plan, and it was asked for. We need to address the atomic world that's coming, and a lot of resources are put into it, and it had guardrails. This just doesn't seem to have that, because there's not there was us versus the Germans and maybe the Russians in World War II to race for the atomic bomb. Now anybody with a few $1 billion can get into AI, and
but
everybody's doing it.
yeah,
Right.
but that might be another scenario. Like if you think worldwide, now you're competing AI with countries such like China. So
Yeah,
maybe now the competition would be more in terms of like uh, how can we develop better this technology? Like it was in the 60s trying to go to the moon. Now, like China is
right.
competing to see what they can do with AI, but bringing to our weather world, I do believe that it's going to create more inequality that we find nowadays because how AI is going to work with countries that don't have this kind of data or this kind of data process.
Yeah,
I
that
mean,
inequity there of other countries. That's true. Yeah,
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 and
so
oh, yeah, I was just gonna say, well, like when anyone, I'm gonna guess everyone that's listening, or most everyone is listening, or is watching or listening, has got some sort of streaming service on their connected TV, which is really just a
right,
giant computer with a giant monitor that looks like a TV these days.
right.
Um,
Right.
that recommendation carousel, and I
Yeah,
work for a large streaming company, I'll be general here, but we build models that based off of like companies like Netflix, you have an anonymized tracking ID in your application so that people like me as a data science, I don't know that that's Mark
right.
Sudduth's TV at his house in North Carolina. It's just some randomized ID, right? But that ID relates to every time you've pressed pause or rewound, or how many times you've done it in a session, how many sessions you've had in a day, how
Yep.
long you watched, how many times you rewatched content, what percentage completion of the content did you know, what other things are watched on other devices that aren't necessarily marked with other people in the household. And all of that data is collected in our what we call our telemetry, or in our measurements, right? And then that data is used to predict what you might want to watch next. And so the up next in your carousel is usually going to be your behavior. If you just started your service, you're getting something that's generalized for everyone. Most people who just started watch this. But as you generate history, that changes your predictions in a way that's unique just to you. And so that, you know, that's already happening at an entertainment scale,
Yep.
but now it's happening everywhere, and up to the point to literally as you're getting to go to a break on your device, right? So let's say you're watching a college basketball game and there's an ad break coming up. An ad server for your service will fire a request for bids across multiple different marketing campaigns that are live, and then pick in almost real time which
For
ad
you.
you're going to see based on who bid the most for your attention at that moment in that
Yeah.
context that you're in.
Surveillance
It's
capitalism.
everywhere. That's exactly what it is. That's exactly what it is.
All right, I'm gonna close the show down, and I'm moving to that Peter Sinks, Utah, and living in that bowl, that beautiful meadow, in a log cabin. It's been real.
You're gonna get
That's
an ad for that in about 20 minutes. So
yes,
just
I will.
give you a heads
It's
up.
gonna be like that
Provo.
Apple show with the Pluribus from Vince Gilligan, where they're and it's not too far off. It's almost like
You
a
know,
Apple
that
version of Black Mirror.
no, that's I mean, I think, and I've watched the whole, I've certainly seen the whole first season of that, and I think that's kind of one of the points, although it's much more complex than that. It's like,
Right.
the aliens can tell someone what somebody thought 20 years ago on this date about this thing because it's
Right.
recorded in some memory that they have. We're not there yet, but that's the societal danger of what
Right.
we're creating. And if the
Poor
guardrails aren't
Carol.
there, yeah.
And I see where Apple is showing ads in the airport says Carol, whatever, and people. Somebody said anybody named Carol that doesn't know the show, they're going to think they need like a mental evaluation that they're talking to me. Wow, Mike. We got to do this more as we go forward. We'll have to just have a new segment, Brave New World with Mike Watkins or something, because this is something else. And the algorithm. Uh, if you thought that was an alien concept and whatever, screw the algorithm. This AI stuff is just mesmerizing. It really, really is.
Yeah,
Um,
we'll train it on Huxley's book, right? But then we'll add to it with whatever we do
right,
in our Brave
right,
New World. Yeah.
exactly. Good reference there. So speaking of algorithms, Mike, hang on. We got to, and you too, Marcel. We're going to get into the last few segments of today's show. One of the things I like to do each time is go over what I call rumors of storms. I heard it through the algorithm, and it's that old play on words of I heard it through the grapevine, of course. And the beauty of this, of course, that is a Chat GPT generative AI cartoon that took me 9 seconds to create, and again, 5 years worth of running a microwave at full speed to create, probably. And there it is. I have a nice, cute little graphic. This time, and again, the point of this segment is to not besmirch people, burn them down, or gatekeep them. It's just we're looking to see if the rumor has any merit and try to unpack it logically and scientifically. We're not trying to upset people, so make that very clear. To that point, Doug, how do you say that name? Kammerer? That's the I don't know. So Doug, who is NBC Washington's chief meteorologist, so he's up there in the DC area. So not a nobody, right? It's not some quote kid on the internet posting a TikTok video. And I love it when people do this, and I've done it before. We've all done it in the enterprise. Don't look at the 18Z GFS. Don't look at the 18Z GFS. Laugh out loud. And of course, what everybody does is they go and they look at the 18Z GFS. I did it, and this is what it showed. This was yesterday. the 18Z GFS. I was waiting, all right, where is it? Where is it? Where is it? And then it was like, oh, there it is, right out at hour 240. Big time snowstorm in the mid-Atlantic, right through DC, which of course is right in here. That
Yep.
is why he would have said anything about it. So then we look and see, does this have merit? You know, again, not to besmirch him, but would the pattern support this? And we talked about that yesterday, that John Hominock and Eric Webb and others have been saying, Ben Knoll, that the pattern as we get into January could favor more wintry weather in the east. And the GFS was sort of firing a warning shot there. And it meteorologically makes sense. But the problem is, and Mike, you can address this, let's look at the actual snapshot. That's 240 hours out. Nice Arctic high sitting up here in a good spot.
Mhm.
Cold air in position. You have your surface low, plenty of moisture. You know, meteorologically it makes sense for the time frame, you know, just the deterministic output that we're looking at, but it's 240 hours out. So as simple as you can put it, Mike, why is that not reliable? And don't just answer, well, it's just too much chaos. That's not a good answer.
Yeah, because of entropy, Mark, that second law of thermodynamics. No, the thing is each so if you think about our ability to predict what's going to happen in the next hour, right? We know a lot of stuff that has conditional but immediate bearing on the next hour, right? We know a cold front, for example, is passing through South Florida right now. We know the winds have turned to the northwest at 20 miles per hour at the surface. We know from observations to the north that there's tremendous amounts of cold air up there. And so we have a pretty good idea that it's going to be cold in Miami tonight, right? So we're going to get down to 48 or something like that. But we could be off a little bit. And so we've been seeing our forecast, for example, down here
There
a
you
couple
go.
days ago, the forecast was 55, then it was
Yep.
52. Now we're at
Yep.
48. Because as we get closer to the event in time, the less uncertainty between the prediction and when it's going to work out, right?
Yep.
So when you go out to 240 hours,
Yeah.
if we, like I mentioned, solve 1 hour at a time, 240 times, any error that gets captured in that matrix
Starts to
propagates and becomes bigger over time. Yeah, so it's like the
Right.
Lorentz and the butterfly effect and all of those concepts with the butterfly flapping in sweeps in Africa. If we can't measure it, even if we
Yep.
can measure it, if we can't get it in the model and explain it in
Right.
time, it's not helpful. And so it's just error propagating out over time. And so the approach of the ensembles is, all right, let's account for that error, that observational error and uncertainty by randomizing initial conditions to come up with a general prediction that may not be too specific for one particular branch of that tree that I was mentioning earlier. But even then, there's just, you know, if you multiply like the odds of flipping heads on a coin twice in a row, right? You
Right.
start at 50%. That means if you want to get heads twice, you've got two independent events, 50% times 50%. So we know that you multiply zero point 0.5 times zero point 0.5, that gives you a 25% chance of doing it twice in a row. Once in once every four attempts, you'll get heads twice.
Right.
Now try to do that 240 times, right? And your probability of getting it right goes down to
Yeah.
virtually zero
Yeah.
at an event level. Yeah. So that's so we don't know enough about the atmosphere to account for the error in what's going to happen, and B, we don't have the observational power to get it into
Right.
a model and time to use it to forecast. So
Right.
uh, those are our two big constraints, are observation and computational power.
Well, to what you just said, and Doug refines further his statement. He says, as I'm saying on air, we have the ingredients. We just don't know what kind of pizza we have yet. And that goes to what you're saying. The cold air, these larger puzzle pieces, the pattern is easier to predict because they are larger pieces of the atmosphere. And so those are more than likely going to be in place, the very deep, cold Arctic air. But then it's the other things, the storm, the track, and any uh, deviations thereof can have big implications on the forecast down the road. And so, again, that's why I like to unpack this from the perspective of, okay, we see the model showing something, and in this case, it was the this big storm, this big winter storm that would sock the DC area, but it's far out in time. What are some of the, how could we get there? It's almost like, Mike, you and I have talked endlessly about Duke and Kansas and basketball. And you want to win the game. And then before all these big games, they have commentators that discuss keys to the game. And sports and weather are more related than people think. A lot of it is probability and statistics, right? Except one is humans and their physics, the other is the atmosphere and its physics and thermodynamics. But it still comes down to probability in our world. And you just have to look and see what will it take, and to Doug's analogy, to get that pizza, which I'd call a meat lover's pizza with extra cheese for Virginia, the DC area, whatever. How do we get that pizza to happen? And then we backtrack from there and see. And then we try to look at it each day. And an interesting way to do that is to look at hour 240 and then go. And I love Levi's site here. What a beautiful thing. How about the next run? It's a bunch of rain in DC. So, Mike, you have to say, and we can do this all day, what changed? Obviously, something changed, because the very next run at that same validation time, you don't have the big snowstorm. Instead, you have cold rain.
Right.
Very interesting stuff. It is. And if AI can solve this, where 10 days out, you see that and you can start banking on it, then I will be very, very impressed.
Yeah, and the sports analogy is a perfect one because there's a lot
Oh,
of
thank you.
uncertainty, right? Like last night, Miami played Denver, right? Denver has one of the best players in the world on their team. He's like 7 feet 8 tall and
Yeah.
can shoot 3 pointers and can do everything you can possibly think of in basketball, right? And so knowing his history and everything he's done up to this point in his career, Denver was likely expected to win by some margin. I don't know, but I'm sure they were expected to win by 10 points, let's say. But then he got injured around the beginning of the first half and didn't play in the second half. And now the game script completely flips because different players have to step into his role. And the model would never know that was what happened because in his history that hasn't been a
Right.
component. And even it was, it might be one tiny solution out of
Yep.
millions. But because it happened that way, Denver lost by 20 points or something like that.
Wow.
And
I
that's,
love it.
in a 2 hour window,
Right.
and not 240
Right.
out into the future. Right.
That is
Exactly.
a great way to bring it home so people can understand it. I love that. That's just terrific. Wow. So we'll see. Big snowstorm for the DC area in about 10 days. The pattern may or may not be there. We'll check in tomorrow and beyond. So, CJ, Marcel, we'll wrap this up here in a minute. CJ, any thoughts from you before we say goodbye to Mr. Watkins and call
No, it
it a
was just
day?
very interesting. Very interesting to just be a fly on the wall and listen to what's really going on. I think it's going to be a big impact on the science, regardless of which way it
Yeah,
turns. It's already
that's a
made its
whole other
impact, and I
world
think,
out there. That's
yeah, and
that's
I think
amazing.
we're just going to see more and more of it as we move forward.
How about you, Marcel? You're from Brazil. Is the Brazilian meteorological community, you still probably keep up with everything? Like it's a big country, modern. Um, it's got to affect. What are your colleagues back home in the college, the universities? I mean, what AI, the weather world? What's Brazil think about it? What's the Brazilian perspective?
Yeah, we're a step behind like most of the countries because we do have um, our own GFS. It's called
Right.
Cosmos, which comes from the German model. So, but doesn't use it
Right.
AI because we don't have statistic enough, like data enough to incorporate this. I do believe that, like I said, I mean, the rest of the world is like a step behind. So
Gotcha.
United States is leading that, and
There's,
the
yeah,
only
there's,
one that who can reach it is probably China or
yeah, so
Japan, maybe.
US, China, AI superpowers, very interesting stuff coming. Well, Marcel, safe travels down to LA, and Watkins, we were talking earlier again, if we can get Marcel to Yeah, hey LeBron, like some kind of a yeah, just throw him off right before that 3-pointer or whatever. Maybe we can win a little money on the side. Put the whole modeling thing into use. We'll
Yeah,
see. We
we'd
got a
call
guy
that
on the inside.
yeah, we'd call that unexplained variance in the modeling world, right? Things that you can't account for in the model. And I think, if there's one last thing that I would stress to everyone, and we say this all the time on Twitter, but especially, and I'll put it in the context of hurricane forecasting. If there's a storm that's 7 days away from landfall somewhere in the U.S., anyone who tells you that they know that that's going to make landfall someplace, or they know
Right,
for sure it's going to do something, you have to disregard that person because nobody knows. The
right,
science is dealing with uncertainty, and so as we get closer to an event, the uncertainty cone gets smaller. The cone of uncertainty with the National Hurricane Center forecast is much smaller at a predicted point an hour or a day from now as opposed to 7 days from now, because what we don't know again compounds over time.
yeah,
And so the biggest thing, and I think the biggest application of weather forecasting and to what we do in the weather world and storm science and chasing and intercepting, is uh, understanding we don't really know what's going to happen. Your next goal is to try to eliminate as much uncertainty as you possibly can to come up with the most reasonable or most likely scenario. And so you see it all the time in the Hurricane Center. We might have the Euro with the track that's 400 miles east of the GFS. So
right,
generally speaking, what are they going to do?
right.
Take the middle of those two to reduce your forecast error on either side of the vector, right? And then adjust over time if one seems to be performing better than the other or handling the atmosphere better than the other. Uh, that's the science. And so anyone who knows is that's snake oil. Anyone who understands that there's uncertainty, that's the science. And so all of these models are going to help us reduce uncertainty, but we'll never be able to get it down to the point where somebody could have predicted yesterday afternoon that Nikola Jokic would have a knee injury at the end of the second quarter. It's just, I don't think we'll get there in our lifetimes, if we ever get there. There's just so much we don't know because of the second law of thermodynamics and entropy and the randomness of the universe. But yeah, listen to the folks who um, communicate uncertainty and make that a part of how they solve problems. That's the best place to look for the
Yeah, I
answers that you
mean,
want.
even J. Robert Oppenheimer told General Groves that the chances of their Trinity test destroying the world were near zero. He didn't say it's absolutely not going to happen. He was very, yeah,
Yes, and
hard.
I laughed so hard when I heard that because yeah, it's not zero. I mean,
Right?
it's almost zero, but it's not zero, and there's a big difference between those two things.
It really is.
Mhm.
And we're all still here, so he was right. Well, very good. Everybody, thanks for hanging out and chatting. This is one of
Absolutely.
the longer shows, and wow, I'm gonna go take an Advil or two to get my headache to go away from all of this learning that I've done about a subject that is rapidly evolving, this AI
Yep.
stuff. We'll be back tomorrow. It is Wednesday. It's generally whatever Wednesday. We'll see what I talk about tomorrow. We'll see if any big storms are coming. The usual stuff, taking a look at the daily highs and lows and everything in between.
Yep.
And we'll get ready to ring in the new year really soon here. And we'll take a look at 2026, what's coming up, some of our plans, so forth and so on. And yeah, that's about it for me. CJ,
Thanks, guys.
Marcel, safe travels with you and the family. Mike
Thank
Watkins,
you.
thanks for joining in. I am
Thanks,
Mark
Mark.
Sutta. This is Talking Weather. We'll see you again tomorrow.